Okay, so this is for question 1. This is for vectors assignment question 1 relative to an origin O. We have the points A and B to have the position vectors 2, 1, 2, 3, negative 2, P. Okay, so if you write it in column vector form, this is 2, 1, 2. This will be 3, negative 2, and P. For P equals to negative 8. So let's look at part A. We want to find the length of the projection and the projection vector of OB onto OA. Right, so here's how we're going to go about doing it. Okay, we recall that in our notes we know that if we have two vectors, let's say we just call them A and B, right? Then if we want to find the length of projection of A onto B, so remember that it's A, here we're talking about A onto B. Alright, so we have to specify that this is the one vector B is being projected upon. Alright, and vector A is the one that's being projecting, okay, projecting. The B is the one that's being projected upon. Then the length of projection is as though we have to cast a light, right? And it will need to be the shadow that's casted by vector A. Okay, so for this vector over here, right, the length of the projection, okay, is none other than A dot product with B hat. Okay, then if we were to talk about the vector of projection, itself, the vector of projection will be equals to A dot product with B hat, right, and we'll use this as a scalar to add a B hat itself. Alright, so now for this question, we are looking at the projection of OB onto OA. So if we just sincerely use this formula here, we are looking at OB being projected onto OA, and this will be our OB, OA hat, and this will be OB, this will be OA hat, okay, and OA hat. Alright, so what we're going to do next, very simple. Okay, we see that we have OB, and next one we have OA. Right, this is our OB, OA. We are finding the length of projection of OB onto OA. Right, so for this vector, is simply the dot product of OB onto the unit vector of OA. So for the unit vector of OA, all we need to do is we take the vector and divide by its own magnitude. Right, so this will give us the length of projection. Right, so this gives us the length of projection. Right, so let's quickly find this. What's OB? OB, as we know, would be 3, negative 2p. Alright, 3, negative 2p. However, we is given that p is equal to negative 8. Right, so it means that over here, p will be equal to negative 8. Right, scalar product OA. OA would be, so OA over here is 2, 1, 2. Alright, and for the magnitude, right, we can actually put it outside. So we can write it as 1 over 2, 1, 2. So over here, if you look at the magnitude of 2, 1, 2, right, the magnitude of OA is actually the square root of 2 square plus 1 square plus 2 square. So actually is equals to square root 9, which is just 3. Okay, so this is just 2, 1, 2, like so called divided by 3. Alright, but we don't do this divided by 3. What we do is we just take the 3, we put it outside. Okay, and this is the length of the projection vector projection. Right, so doing your scalar product 6, negative 2, negative 16, you're going to end up with negative 12. Right, and 1/3 outside, 1/3. So you're just going to end up with negative 12, 3. So modulus of negative 12 is just 12 divided by 3, which will give you 4. Right, so this is the length of projection of OB onto OA. Alright, what about the vector of projection? Vector of projection, based on what we know, vector of projection OB, OA, right? The vector of projection Okay, based on what you study in the notes, this will be actually OB dot product with the unit vector of OA, right? Okay, multiplied to, sorry, not dot product, multiplied to the unit vector of OA. It's not dot product, it's just, right? So this, as we have found earlier, is actually negative, actually negative 4, right? Because if you look over here, the answer is a modulus of negative 3. So actually this is negative 4. From here we actually found that if we just look at OB dot product with unit vector of OA, right? Right, if we do not take the magnitude of it, it actually is negative 4. So from part A, we have found that this gives us negative 4. Okay, magnitude of OA is actually 3, as we have found just now. OA, the vector is 212. Right, and our answer turns out to be negative 4 over 3 bracket 212. And this is the length of vector of projection of OB onto OA. Okay. Okay, so next for P equals to negative 4, we need to calculate the exact shortest distance from B to the line passing through O and A. Right, so what we need to do, from B passing through the line through O and A. Okay, so OB, OA. The shortest distance from B passing through the line through to the line passing through O and A is none other than, we're talking about this line, right? So how do you find this line? There are a few ways to go about doing it. So number one, in the past, remember that if we learned this before. If this is A, this is B, and we want to find the shortest distance, right? Now what we can do is we just take A. This is just A times times the unit vector of B, right? So it's the same for this. In order to find our shortest distance, what we do is we take OB and scalar product this with the unit vector of OA. Okay, and this will give us the shortest distance. Alright, same, because we're finding distance, we need to take the magnitude. Okay, then after that, all we need to do is just plug in our numbers. OB is another than, because P is equals to negative 4, so our OB over here will be 3, 2. Now P is negative 4, so we have a negative 4. Vector product with OA modulus OA, so this is again 1 over 3. OA is 212. Alright, again for vector product, what you can do is you can just throw the 1 third outside. Okay, and solving what you get inside, you will have the vector 0, negative 14, 7. Alright, so right, all I need to do is just find the magnitude of this number here. Alright, so the magnitude of this number here is you can just take off. In fact, what you can do is you can even take out 7. So if you take out the factor 7, alright, you end up with the number 0, negative 2, 1. And this will be even easier for you to compute your magnitude. So it's 7 over 3, right? 0 square plus negative 2 square plus 1 square, and you will end up with 7 root 5 over 3. Okay, so this is the answer for part B. This is the shortest distance from B passing through the line OA. Alright. Okay, so next let's look at C. Okay, for C, we want to find the value of P for which OA and OB are perpendicular. Now this is easy because we know that perpendicular vectors means that one thing that comes to your mind is that the scalar product will be 0. Okay, so if OA and OB are perpendicular, so let's say if we are saying that we want them to be perpendicular, okay, based on your understanding, you know the scalar product is 0. Right, so remember, because okay, the scalar product is the cosine theta, because you know cosine 90 degrees equals to 0, right? And A dot B are perpendicular. This means that you know A dot B, this is also equals to modulus A, so magnitude of A, magnitude of B, cosine theta, where theta is angle between A and B. So cosine 90, because it's perpendicular, if it's equals to 0, this means that this equals to 0, right? So with that, if OA and OB are perpendicular, this implies that OA dot product with OB will be equals to 0, right? This implies that OA, which is 212, OB, which is 3 negative 2p, alright? So we do not assume that here the value of p is back to negative 8 and negative 4, there's no other difference. So this would be 6, negative 2 and 1, that minus 2, 2 and p, we have plus 2p equals to 0. So you have 4 plus 2p equals to 0, and p will be equals to negative 2. Alright, this is the answer for part C. Okay, how about for part D? So what's the question for part D? For part D, right, in the case where p equals to 6, we want to find angle AOB correct to the nearest degree. Alright, angle AOB, okay, simple. All we need to do is angle AOB cosine, right? Because scalar product, we know that very quickly, one property that comes to our mind is that cosine theta, this is the A dot B over magnitude of A, magnitude of B, right? This is from scalar product. So cosine angle AOB, alright, this is just OA dot product with OB over the magnitude of OA and magnitude of OB, and the magnitude of OA. So OA is 212 here, because in this case p equals to 6, and we have OB to be 3, negative 2, 6. Alright, magnitude of OA, as we have found earlier, is square root 9. Magnitude of OB, you can actually find this by yourself. This is magnitude of OB over here. This is the square root of 3 square, negative 2 square, 6 square, which will actually give you a square root 49, which is 7. Right, so it's actually square root 49 over here, and this will eventually give you solving, you'll get 16 over 21. Okay, so I'll leave you to do it by yourself. And if you have cosine angle AOB to be equals to cosine is equals to 16 over 21, then very quickly angle AOB, you can take the cosine inverse of 16 over 21. Alright, approximately this will be 40 degrees, right? Because we are finding the answer to the nearest degree, right? Because in our questions earlier, they have told us that we want to answer correct to the nearest degree. So we'll just come back here and say, okay, alright, let's run it off to 40 and to the nearest degree. Alright, so last question, we want to find part E. Okay, in the case where p equals to 5, we find the position vector of the point M on the line segment AB such that AM is to MB is 1 is to 2. Alright, so we see a ratio. Naturally, the thing that come to our mind is that we can think about using a ratio theorem. Okay, AB, we have the line AB, AM, MB is 1 is to 2. Alright, and AM, this is AB, right? AB, AM, M lies on the line AB, ratio here is 1 is to 2. Now very quickly, if I use the ratio theorem, origin, OA would be equals to 212. Alright, and P equals to 5, so OB, this will be equals to 3, negative 2 and 5. Alright, so using ratio theorem, remember ratio theorem, we just crisscross, right? Okay, this way. Right, so very quickly, OM would just be equals to 1 of 3 negative 2, 5 plus, okay, let me just write this neatly. Okay, 3 negative 2 and 5 plus 2 of 212 divided by 1 plus 2. Alright, and very quickly you can actually solve this by yourself, and you will get the answer 7 over 3, 0 and 3. Alright, and this is the answer for part E of question 1 for your vectors assignment. Right, so vectors 1 assignment question 1.